Hello children, this is your Ranjit sir. We are studying 8th standard mathematics under the topic rational numbers. In this video, we will learn the properties of rational number. We will cover exercise 1.3 in your textbook. The subtopics are closure property, commutative property, associative property, and property of zero. Let us see an example, children. Imagine that you are in 5th standard and you are writing your maths exam. In your question paper, two sums are given. The first sum is 10 minus 3 and you have written the answer as 7. The second sum is 3 minus 10. When you look at the sum, what would your response? You will immediately stand up and say, "Ma'am, this is a wrong question." Why do we say that it's a wrong question in 5th standard? But when you come to 6th standard, what would your answer for this question? You are right, it is minus 7. So what makes the difference? It is nothing but the closure property. So what is closure property? It is very simple, children. When you take few numbers and mix the numbers or solve the numbers using addition, subtraction, multiplication or division, whatever it is, you can do that. And the resulting answer you get should also be in that same number system. For example, if you take these two sums A and B, 10, 3 and 7, all these numbers from sum A belongs to natural number system. But when you come to sum B, number 3, number 10 and the resulting answer minus 7 do not belong to a same number system, as 3 and 10 belongs to natural number system and minus 7 belongs to integer number system. So we say that it's a wrong question. Understood, children? So let's define the closure property like this. When A plus B is equal to C, where A, B and C are rational numbers. This is for addition. Let's take an example. 1 by 5 plus 2 by 5. 1 by 5 is a rational number. 2 by 5 is also a rational number. When you add these two numbers, what would you get? We have to add the numerators 1 plus 2 and the common denominator should be written as 5. Your resulting answer will be 3 by 5. So this 3 by 5 is also a rational number. So we say that closure property for addition is true. That means that you can use any number from rational number system. When you add it, you will always get a rational number as answer. Let's see the same property for subtraction. What does the property says? A minus B is equal to C, where A, B, C are rational numbers. Let's take an example. 7 by 4 minus 2 by 4. When you subtract this, what would be your answer? Yes, subtract the numerators. 7 minus 2 by 4. Your resulting answer will be 5 by 4. So this 5 by 4 is also a rational number. So what do we understand, children? When you take any number from rational number system and subtract it with other numbers, you will always get a rational number as answer. That's what it means. So when it happens like that, we say that the closure property is true. Let's go to the second property, commutative property. What is this commutative property? Commutative property deals with the order of numbers. Let me repeat. Commutative property deals with the order of numbers. Like you have few numbers here, 2 plus 3 plus 8 plus 7. When your teacher asks you to add this in your lower classes, you would have added this in a different way. How do we do it? We rearrange the numbers. We take 2 and 8 and add it. Then we take 7 and 3 and add it. We change the order of numbers. The first number was 2 in the question, and 3 is the second number, 8 is the third number, and 7 is the fourth number. But we rearranged it in a different order. What is the order which we rearranged? 2 is the first number, 8 becomes the second number, 3 becomes the third number, and 7 becomes the fourth number. So this change of order can be done when the commutative property for a number system is true for a particular binary operation. Understood, children? So we get the answer for this sum as 10 plus 10, which is 20. So what does commutative property says? If the commutative property is true for addition, it means that you can rearrange the order of numbers and add it. If it is false, you cannot do that. That's what it means. Let's examine this commutative property. A plus B is equal to B plus A. We change the order and we add and check whether it is true. We are taking two numbers to do that. Let's take 1 by 7 plus 2 by 7. When you add 1 by 7 plus 2 by 7, what do you get? 1 plus 2 by 7. The resulting answer is 3 by 7. On the right hand side, we change the order. The first number becomes the second and the second number becomes the first. Now we added 2 by 7 plus 1 by 7. What do we get? 2 plus 1 by 7. Your resulting answer is 3 by 7. So what do we understand in addition? For rational numbers, the commutative property is true. It means that you can interchange the order of numbers when you are adding rational numbers. Let's check the commutative property for subtraction. Actually, for subtraction, commutative property is not true. That means you cannot change the order of numbers while you are doing subtraction. Let's check that. Let's take two numbers, 5 by 7 minus 3 by 7. When you subtract these two numbers, what do you get? 5 minus 3 by 7. Your resulting answer will be 2 by 7. This is on the left hand side. Let's rearrange the order. The second number becomes the first number and the first number becomes the second number. When you subtract it in this way, what do you get? 3 minus 5 by 7. What is 3 minus 5? It is minus 2 by 7. So 2 by 7 and minus 2 by 7 are not the same. They both are two different rational numbers. So when you see these answers, what we can conclude? We conclude that commutative property is not true for subtraction. That means that you cannot change the order of numbers while doing subtraction in rational number system. That's what it is. A minus B not equal to B minus A. Let's go to the next property, associative property. So what is this associative property? It deals with a grouping of numbers. Let me give you an example. On the left hand side of this equation, what I do is I take 7, 3 and 5 and make it as a single group, and I leave out 15 separately, right? So First I add 7 plus 3 plus 5. Why do I do it? We know that when there is a bracket, we should do that operation first. We have learned that in Bodmar's rule. So on the right hand side, we see two brackets or two groups. One is 7 plus 3. The second group is 5 plus 15. So what do we understand, children? We understand that when you group the numbers, right, in a different order or a different way, your answer should not change. That's what associative property deals with. When your answer is not the same, it means that associative property is not true. So let's see in this sum. In this sum, the left hand side and the right hand side are grouped differently, but both of them will give you the same answer. Understood, children? So let's check the same associative property for rational numbers. Let's take three numbers. Let's name them as A, B and C. When you add A, B and C in a different grouping, your answer should be the same. If it is same, then the associative property is true. Let's check this. 2 by 3 plus 1 by 3, it is grouped together with the using bracket, and we have 4 by 3. When you add this, first we will add the numbers inside the bracket. So we get 3 by 3 plus 4 by 3. What would be the net result? 7 by 3. Let's do the same for the right hand side. Now I have grouped the second and the third number together, leaving the first number. What would be the answer now? 2 by 3 plus 5 by 3. When you add these two numbers, what would be your net result? 7 by 3. We see that we have same answer on both left hand side as well as the right hand side. This shows that associative property is true for addition. What does it mean? You can change the group of numbers while doing addition. If they give you 10 or 20 numbers to add in rational numbers, you can simply group them as ever you wish and add it and make it simple. Understood, children? Let's check this for subtraction. See, in subtraction, associative property is not true. Let's see why it is not true. A minus B minus C not equal to A minus B minus C. On left hand side, A and B are a group. On right hand side, B and C are a group. So let's check this. 7 by 5 minus 3 by 5 minus 2 by 5. The first number and second number are a group now. Let's do that first. What do we get? We get 4 by 5 minus 2 by 5. How do we get 4 by 5? By subtracting 7 by 5 and 3 by 5. When you do the further simplification, you get the answer as 2 by 5 for the left hand side. Let's check the same for right hand side. Now the first number is left out and the second and third number are grouped. When you add in this format, what will be your result, children? 7 by 5 minus 1 by 5. Then when you subtract it, you get 6 by 5. Can you see the difference, children? We get two different answers. This shows that associative property for subtraction is not true. So what is the implication of this statement? It means that when you do subtraction in rational numbers, you're not supposed to change the group and do the subtraction. Understood, children? Because you won't get the same answer or a correct answer. Now we will learn the property of 0. What does it mean? We know it already. When we add 0 with any number, what will be the result, children? The same number. Yes, that's what is it. When you check in addition, when you add 13 by 11 with 0, or you add 13 by 11 to 0, I mean the order, the difference in order, you'll get the same answer, 13 by 11. This is called the property of 0. So we call 0 as the additive identity. It means that whenever you add 0 to any number or the vice versa, you will get the same answer, the same number as its answer. That's why we call it as 0, an additive identity. Let's check the same for subtraction. The property of 0 in subtraction is quite different. When 0 is subtracted from any rational number, the result is same rational number. But it is not true with the other side. I mean, when you do p by q minus 0, you will get p by q. But when you change the order, as you all know already, 0 minus p by q, you will not get the same answer p by q. You will get minus p by q. So 0 is not an identity for subtraction. It is an identity only for addition. Thank you so much for watching the video, children. If you have any doubts, please contact me.